Swayam Prabha. Digital India. Educated India.
So far we have seen different kind of circuit elements, resistor, capacitor and the inductors, and along with that different sources, dependent and independent sources. Those will be connected in the form of a circuit and it will form a complex circuit. So in this particular lecture we'll be talking about the solving techniques, which will fall as mesh and nodal analysis techniques. These mesh and nodal analysis techniques will be utilized to solve the complex circuits. So, for example, if we consider one circuit which is having a different number of loops, okay, so this is a one of the easy example, or we can just connect here a voltage source. Okay, this is the ground. Suppose this is the P1, R1, R2, P2 and R3. So in this particular circuit which we have assumed, if we find out the total number of nodes, so suppose the reference nodes n, then voltage, so another node is, so this is A, then another one element, then this node is B, and this node is, and then is coming here. So what we can do, we can just assume one more register just to make it little complex, not very different, but then it will become D. So we have identified the nodes. So when we talk about nodes, we have N, A, B, C, D. So these are the nodes. Okay. Now what we'll do, let us find out the loops. Okay. So first loop, if you'll see, is A, B, C, D, N, A. This is the outer loop. So if we can mark it, the loop is A to B to C to D and back to A. Okay. Now A, B, C, D and A is a loop, and another loop you can see as, what is another loop? You can see as A, B, N and A, B, N and A. So I'll just mark with the blue color only. This is one loop. I'll give a name as L1, and this is L1. And then one loop is B, C, D, N, B. This is L2. B to C to D, N, B. So this is L2. Okay. And this basically a combination of this. When we talk about mesh analysis, let us define the mesh now. So mesh is basically defined as a closed path around a circuit, okay, that does not contain any other closed path within, which means that smallest loop is a mesh. Smallest loop in the sense that it does not contain any sub loop. So if we consider this A, B, C, D, and A, the outer loop, it does not form a mesh because it contains L1 and L2 inside. So basically it contains L1 and L2. Whereas the A, B, and A, the loop L1 does not contain any closed loop or closed path within itself. So you can find that the mesh, so in the above example, mesh are L1 and L2. So basically the independent loop. Okay. These are the mesh. Is that clear? Now moving to the next part. So when we try to solve a circuit using mesh analysis, we have to initially assume a circuit current or mesh current which is flowing in the mesh. So in this particular example, if you want to see, we'll be assuming one current which is flowing in this mesh and another current which is flowing in this mesh. So these mesh currents, so we'll assume a mesh current, right? Let us see this mesh current. So mesh current is basically a hypothetical current which is assumed, okay, to flow within the perimeter of that. So it is a hypothetical current. That flows along the perimeter basically. Okay, that flows so hypothetical current that flows along the perimeter. Okay, so if suppose L1, the hypothetical current I1 will be flowing along the boundary of this L1. Similarly, in the mesh 2 L2, the hypothetical current I2 will be flowing from the A to B to C to D to N, and then again B. So this is a loop. This is the path for I2, and this is a path for I1 for loop 1. Now let us consider an example and apply the mesh analysis. Okay. So if we consider the example, so let us draw a circuit. So let me draw that first. So this circuit is basically having 3 mesh, which you can see clearly now because it is the smallest one, right? Assume this as R2, then R3, then R4, R5, assume this as a R6, and this as P3. So first identify the nodes. In this example, we'll apply the mesh analysis. So identify the nodes. So suppose this is the reference node N. So this is A, this is B, this is C, D, E, and F. So these are the nodes. Now suppose this is a mesh. So node are A to A to F and N. These are the nodes. Now mesh. What are the meshes? This is just for a practice. You need not to write this while solving the equation. It is just to make sure that how will you identify the mesh. So from here, if you see, suppose if we take this as, if we assume this loop as L1, this as L2, which is this loop, and then one loop with L3. So mesh is L1, which is nothing but B, C, D, and F. So this is the one loop. Similarly, another loop is A, B, F, and A, and another loop 3, which is a mesh, which is known as the smallest closed path, which is not having any closed loop within it, or the closed path within it. So this is N, F, D, E, N, N, F, D, E, N. So these are the 3 different loops, which are the smallest loops. So basically the mesh. So now what we'll do, we'll assume so first identify the nodes, then mesh. Okay, now assume the current, mesh current. So we'll assume I1, I2, I3 mesh current in respective loop. So suppose in L1, this is the direction of current I1, this is the direction of current I2, and this is the current direction of current I3. So these currents are hypothetical current. Okay, so now we'll apply the KVL later. First, pay some attention in the resistance D and F. Okay, so draw the resistance. So this is node F and this is node D. So if you see this from the loop L1 side, so you find that one current is going D to F, which is I1, and if you see from this loop side, one I3 current is going from F to D. This is I3 and the value of this is R3, isn't it? So this is the situation. If I apply the KVL, not KVL, the Ohm's law, how will you write it? What is the voltage drop? Voltage drop across R3. What is that? So to find out the voltage drop across the R3, first we have to make sure in which direction the current is flowing. And the direction of current flow, the voltage drop we are assuming as negative throughout, right? In the course, the voltage drop is taken as negative. So assume the direction of the current. So first we'll assume current flows, current in branch DF flows from where to where? From D to F. Now we have fixed the direction, right? So voltage across the R3 in this branch is nothing but negative of R3. The voltage drop is negative. What is net current will be assumed when the current is D to F, means I1 will be positive and I3 will be negative. So this is the logic. Okay. Similarly, if we see this branch BF having R2, so if we draw this, just for the sake of understanding, we have B and we have F. So if you see from the loop L1 side, the current, sorry, this is I1, the current I1 is flowing from F to B, and the I2 current is flowing from B to F. So while writing this Ohm's law, or the voltage drop across this R2, we'll write VR2 as, under what condition? Assuming that current flows from B to F, it means in the direction of I2. So it will be minus R2 I2 minus I1, because we have assumed the current in the direction of I2. Okay, but if we assume the current in the direction of I1, then VR2 will be minus R2 I1 minus I2. So when the current flows from B to F, and when the current flows from F to B. Okay, so this is the difference. So both are correct. Based upon the direction of the current, we'll consider this assumption or the polarity of the voltages across the R2. Now I'll just copy this example. Okay, so we'll redraw this here. Okay, so while redrawing, this is n. So let us consider the example and now apply KVL in loop L1, which is nothing but the mesh. So loop L1 or mesh L1 is same thing, because this loop L1 means the smallest loop. It does not have any sub loop within it. Okay, so now you can start from point B. We can write V1, which is a raise in the voltage potential, minus R1 into I1 minus R3. So we are writing for the loop 1, so we'll assume the current direction I1, which is D to F. So what I'll write, I1 minus I3 minus R2 I1 minus I2 0. Okay, so keeping the V1 the same direction. Okay, so consider the I1. Is equal to 0. So if we take this V1 other side and then just rewrite this equation, so we'll get R1 plus R2 plus R3 times of I1 minus R2 times of I2 minus R3 times of I2. So this is equation number 1. Similarly, if we again apply KVL in loop L2, what we'll get? We'll get V2 minus R2 I2 minus I1, because now we are considering current of I2 which is flowing from B to F. So keeping that in mind, this is the voltage drop, then minus R5 of I2 minus I3 minus R4 of I2 is equal to. Now if we solve this, we'll get minus R2 I1 plus R2 plus R4 plus R5 times of I2 minus R5 of I3 is equal to V2. This is question number 2. Now in the same lines, okay, if we consider this loop 3, okay, now apply KVL in loop 3. Okay, so what we'll get on the similar lines, you just write the voltage drop. Suppose you start from any point, right? Start from this point R5. We are assuming the loop 3, so current will be is going up in N2 F. So voltage drop will be minus R5 I3 minus I1, sorry, I2. This is I2. Okay, so this is, 1 second. Then moving from F to B, we have R3. Then current will be I3 minus I1. Then we have R6 into I of 3. Then we have drop of V3. In the direction of current there is a drop, right? So V3 is nothing but 0. So if we solve this, what we'll get? We'll get minus R3 I1 minus R5 I2 plus R3 R5 R6 R3 plus R5 plus R6 times of I3, nothing but V3. This is equation number. Okay. Now we have three equations. So in this case of three equations, we have three variables. What are the variables? We have to find the values of I1, I2, I3. So three variable we have to solve, and using three equations. Using I1, sorry, equation 1, equation 2 and equation 3. This can be done. So the main task is to write the equation. So the step is first identify the nodes and then identify the mesh, then allot the mesh current accordingly and write the KVL equation for each mesh, and then solve for the variable or the mesh currents. So the interesting part is, if you consider the equation 1, 2 and 3 and write it in the matrix form. So considering equation 1, 2 and 3 and write them in matrix form. Okay, so if we write them in matrix form, we get some matrix here, and then we have variable I1, I2 and I3, V1, V2, V3. So if we just fulfill it, it will be R1 plus R2 plus R3 minus R2 minus R3. That will be minus R2 plus R4 plus R5. Then it is minus R5 minus R5, and this is nothing but R3 plus R5 plus. Okay, so this is nothing but the generalized form of mesh equation. Form of mesh equation. So in this equation, if we see what is the element, this, and then this one, and what is the element, this. So if you see a kind of this, suppose this is the matrix form of Ohm's law. Okay, So this is a matrix of 3 by 3, and this is a matrix of 3 by 1, and this is a matrix of 3 by 1. So for a circuit of m number of mesh, which implies the R matrix will be of the order of m by m, and the variable will be having a vector of m by 1. What are the unknowns? I1, I2, Im. These are the unknowns. Okay. So if you write it in the short form, like if you want to write it, that is a Rm matrix, then this is Im matrix, and then it is nothing but this is so once the all the I1, I2 and I3s are known, suppose in this case, then we have to find, for example, we have calculated the I1, I2 and I3, and then we are asked to find the current through, suppose, this R3. So the net current in R3 is nothing but I1 minus I2. If I1 minus I3, if the current is flowing in this direction, in the direction of I1. If we are assuming the current is flowing in the direction of I3, then it will be I3 minus I1. Okay, the net current in R3 will be nothing but I3 minus I1 if the current direction is assumed in the direction of I3. Okay, so the current, if it is going upward, it will be I3 minus I1, and if it is coming downward, it will be I1 minus I3. So depending upon the direction of the current, the magnitude will be having a sign of positive and negative. Let us consider an example. Okay, so we can have a small example just to understand the procedure. So suppose we have a voltage source, then we have a resistor, okay, so this is R1, or we'll write surveys. This is write 4 ohm. This is nothing but the 10 ohm. And this resistance, if we assume as a 5 ohm, with a battery of for example 8 volt, at this side 6 volt. So this is the given circuit. Okay, now in this circuit, identify the nodes. This is a reference node, this is node A, node B, node C, and assume a current direction I1, I2. So this is the direction of the current which is assumed. Now apply KVL in, this is L1 and this is L2. L1, and write the equation. So when 8 minus 4 into I1 minus 5 of I1 minus I2 is equal to 0. Okay, so if we write, it will be nothing but 9 I1 minus 5 I2 is equal to 8. So equation number 1. Now similarly apply KVL in loop L2. So starting from N again, the current direction is towards the upward. Now in the 5 ohm resistor, it is going towards N to B. So now drop 5, N to B means I2 minus I1. Okay, then we have drop in 10 I2. Then we have a drop of 6 volt, which is 0. So it is nothing but minus 5 I1 plus 15 I2 is equal to 6. This is V means 6 volt. Equation number 2. Now from equation 1 and 2, we can solve it for I1 and I2. So 2 variable and 2 equations. Now suppose if we write it in the matrix form. So in matrix form, right? This will be 9, will be minus 5, will be minus 5, will be 9, not 9, this will be 15. Then this will be I1, this will be I2, 8, this is the, there is a polarity change. Now you can just solve it for I1 and I2. Okay, what is R11 here? It is total loop resistance of 1. So R11 here is 9, R12 is nothing but minus 5, which is nothing but R21, then R22 is 15. This is Rm matrix, this is Im, and this is Vm matrix. Okay, so the element of Rm matrix, okay, if in this particular case it is 2 by 2 because we have 2 mesh. Now R11, the element of the matrix Rm is nothing but sum of all the resistances in loop 1. And what is R22? That is similarly sum of all the resistances in loop L2. And what about R21? R21 will be equal to R12, nothing but common or mutual. Just settle up. So mutual resistance between L1 and L2. Okay, so this is the sum of all the mutual resistances which is shared between the loop or mesh 1 and mesh 2. So this is how we write the generalized form of generalized matrix form of all the equations. So now I'll take one example and write it for directly for the big circuit. So let us consider one more bigger example. Now this time we'll just try to write the direct matrix form. So we have one resistor here, suppose one here and then one here, and this is how they are connected. Let us remove this one source here. So we have R1, we have R2, R3, R4, R5. This is nothing but V1, and then this is nothing but V2, and this is nothing but V3. So assume current direction 1, 2, 3. Okay, so this is the current direction. Now if we talk about the element R11, what you can see, the total resistance is sum of all the resistances, which is R1 plus R2. Now R12, the common resistance between loop 1 or mesh 1 and 2, which is nothing but R2. R13, okay, here I forgot, this magnitude will be taken as negative. Here the mutual terms will be taken as common mutual resistance between 1 and 2, the negative sum of that, I mean with the negative polarity. This will be like opposite polarity, negative terms. Mutual terms will be taken as negative. So R13, R11, R1 plus R2, R12 is R2, which is common between this and this. Now if we consider as R13, it is nothing but 0 because there is no common branch between the mesh 1. Okay, L2 and L3. So there is nothing common between L1 and L3. Similarly, R22, what is that? R2 plus R3 plus R4. What is it? R1? R21 is nothing but R12. It is nothing but minus R2. What is R23? The common term between the mutual term between 2 and 3 is R4, which is negative R4. Similarly, what is R33? It is nothing but R4 plus R5. What is R13? Zero, or basically R31, right? R13 and R31 will be 0. What is R32? Minus R4. So if this current is assumed to be I1, I2, I3, we can write this equation as R1 plus R2 minus R2, 0, 0, R2 plus R3 plus R4, then R23 is minus R4, then this is 0, R21 and R12 is minus R2, and this will be minus R4, and this R33 will be R4 plus R5. So this is the terms, which is nothing but the I1, I2, I3, and it is the sum of all the voltages. Now what is the total voltage? The total voltage, if you see in the direction of current, if it is rising, it will be taken as positive. Now what is the total voltage appearing in the mesh 1, which is supporting the current this to flow? So we see that both the currents are opposed by this V2. So these source will try to produce the current in this clockwise direction, and this current this source will be trying to suppress that. So this will be nothing but V1 minus V2. And here in this case, the current is assumed to be in this direction, so it will be taken as V2. And here the current direction is basically opposite to the source, so it means that it will be taken as minus V3. So basically what assumption we are taking is whether the current is being supported or opposed by the presence of source in the particular mesh. So based upon that, this polarity will be given. So this, what you can do whenever you're trying to solve, first write the KVL equation, then form a matrix, and then practice it. So that will be helpful in understanding the mesh analysis.